I got my own headline over there, and I'm going to talk about plastic pollution, apparently. And I will challenge you a bit by posing the question whether it's really the macro problem that we perceive it to be, or from a scientific point, whether we can consider it rather a micro issue. I'm going to start with an image that probably all of you have seen somewhere across the social media, in the news, in the newspapers. It's a carcass of a Laysan albatross found on Midway Atoll. It's a very emotional, very powerful image, so it contains like decay, it contains death. It also contains somehow persistence, right? So you see like while the albatross chick is apparently dead, something's in there that will persist. And I will make the argument that it was this kind of images, those really icons of the Anthropocene, that have really driven a cultural shift in the perception of plastics. And I would make the argument that we're seeing this cultural shift towards a global consensus that plastic pollution is really unacceptable. So we're not seeing any plastic pollution deniers. There's no argument really about it. Even plastic manufacturers wouldn't dare saying it's not an issue, right? And based on that, we see this incredible momentum to mitigate the problem, to really act on it. So we are discussing shopping bag bans, we are discussing cosmetics that don't contain microplastics, don't contain microbeads, we're discussing banning straws, etc. So there's this whole lot of activities going on trying to make positive change. But here's the thing, right? I'm a scientist, and I mean, we are literally still sitting on the beach counting those lovely, colorful, tiny fragments that we call microplastics, and we're really perplexed what's going on. Because, naturally, I've been working on endocrine disrupting chemicals for quite a while, and we're really having this tremendous body of evidence out there, and we're having this hard time really making societies realize that that's something we need to do something about. And now here we are sitting at the beach, and societies are really moving far ahead, far beyond the scientific evidence. And that's something that's really, really an interesting situation to be in as a scientist, right? So I would say there's a lot of uncertainty about plastic pollution, and yet societies are asking us, what can we do about it? Let's do something. Super perplexing, interesting situation to be in. So in my talk, I will talk a bit about what we actually know about the risk of microplastics with regard to environmental impacts, and that's more the natural science part. But then, because I'm so perplexed being in this kind of weird situation, everybody wants to do something while we actually don't know a lot, I will also be a bit more on the soft science side, and I will talk a bit more about kind of the factors that have really formed public opinion on plastics and microplastics. So let's stick a second with the environmental impacts of microplastics there. And of course, there is evidence. Research has grown over the past 10 years, so we know a bit about what microplastics are doing in the environment. And we can apply like this kind of framework of risk assessment, which we have for chemicals, for synthetic chemicals. We can apply this framework to microplastics as well. And the basic paradigm is, of course, for risk assessment, that you compare the exposure, so the levels in the environment, to the hazards of microplastics. So what is their impacts? What is their toxicity? And even though the science is not really mature, I would say, there's a lot of uncertainty, we can do that based on the evidence that we have. So let's talk a bit about the exposure. I won't go really into detail because, again, you all have seen the paper, the images, the pictures. So that's a pristine beach. That's a natural beach today. This picture has been taken on Henderson Island, which is the remotest place on the globe, 3,500 miles away from civilization, 16 tons of plastic litter accumulating on the shorelines. So I don't need to convince you that we know that plastic pollution is pervasive, it's ubiquitous, it has a global scale. 90% of the research is done on really the environmental levels of plastics, including microplastics. We just find it everywhere. It's in the deep sea. It has been found recently in very high levels in Arctic sea ice, a place, the Arctic, we believe, is very remote and pristine. It's there as well. So what we know from scientific evidence is really it's ubiquitous. We can look at it in a bit more quantitative way over here. And what you see, this is like a meta-analysis of the levels of microplastics in freshwater ecosystems, which I care a lot about, so rivers and lakes. And what you see is that the levels really, if I see where this is, that the levels really vary. From this kind of meta-analysis, you also learn that in Asia, the levels are somewhat higher than compared to North America and Europe. But the take-home message from this kind of meta-analysis is that in the most polluted places, we find between 1 and maybe 800 pieces of microplastics per liter. So that's like the worst-case exposure we can talk about. Let's talk a bit about the hazards of plastics. And this is, I've drawn a very crappy animal here. So this is supposed to be an animal, just very schematic, you know. And I will just talk you through like the way how we think in a systematic way about the impacts of plastics and microplastics. I don't need to talk a lot about entanglement, right? You again have seen the pictures, animals getting trapped in ghost nets, for example. We know today that more than 550 marine species are affected by entanglement in plastic. So that's, of course, a serious concern. But for microplastics, then we think like that ingestion is the main route of exposure. And there's a bunch of laboratory studies that showing that a broad range of species is really ingesting microplastics, either because they cannot discern between natural food and plastic pieces. So there's kind of ingestion going on over there, and that will result in internal exposure, so to say. It's very important to highlight that there is often a misconception in that ingestion is indeed like toxic or adverse by itself. It's just a matter of exposure for me as a toxicologist. But what can happen then is that we're seeing kind of an accumulation of plastics in the digestive system of an animal, and that will reduce the energy intake, and that might result in starvation, and there are studies showing that. For the very small pieces of microplastics or even nanoplastic, there is this idea that they pass across biological barriers. So they don't stay in your digestive system, but they will translocate to tissues, which might cause injuries and inflammation. It's important to realize that that's all like physical interaction, physical toxicity, which makes it very different from all the chemicals we talk about. There's also, however, this kind of chemical vector effect, how we call it, or Trojan horse effect, and that's very hotly debated in the scientific community. So we know that plastics contain a lot of chemicals by themselves, all the additives. We know that they're very good in absorbing all the pollutants from the environment because they're hydrophobic. And it's a very special case because it's really context dependent. It's not that the evidence is not that clear cut. So for example, it depends on the plastic and the chemicals you look at. It depends on whether the animal is pre-exposed with other pollutants or not. So there was a lot of kind of discussion in the community whether that's really relevant. Recently, I see there's a consensus forming among the experts, really, that the exposure of chemicals via microplastics is of rather minor relevance. And we think that's the case because, like, exposures from food, for example, to all those persistent organic pollutants, we believe is much more relevant than from the few pieces of microplastic that an animal is ingesting. Let's look at the hazard in a more qualitative way over there. That's a species sensitivity distribution plot. So you see up here, that's green algae. You basically need to bombard them with billions of particles, very insensitive. But you see more sensitive species over there, really. And from this kind of meta-analysis, we can conclude that there is a hazard in very sensitive species at a concentration of about 100 to 1,000 microplastics. And then it's very simple to do the risk assessment. You see again here, that's the environmental levels, that's the concentrations that we consider to be harmful, and there's a gap in between. And that tells us that the levels of microplastics in the environment we know about are currently lower than the ones that we expect to be of a risk. You also see a very small overlap in the two distributions, and that tells you that at present there's at very heavily polluted locations there might be a risk at present. That's what we conclude also in this kind of report, where we summarize all the evidence of microplastics for the European Commission in an expert group. We say that the ecological risks of microplastics, based on the current knowledge, are rather low. However, there might be heavily polluted places that are already affected. But there is a very important concern that we put in here as experts, and we believe that if we continue a business as usual model, then of course emissions will increase, and we are quite concerned that we will see a widespread risk of microplastics within a century. And for me, that's a very powerful argument, of course, to start acting right now. I'm talking too slowly, so I'm getting like yellow cards, and I will skip over all the fancy social science stuff that we did. I just want to highlight one thing. I'm still very interested in this kind of idea that why is it that we scientists think about what is there a risk, is there an impact? Why is it that the public is really so afraid? And I believe one factor that's really driving this is differences in risk conceptions. So when a scientist is saying microplastics may be a risk, she or he is thinking about, okay, we don't know, we need to find out, that's our research agenda, that's our hypotheses. But when this is communicated to the public, that maybe that uncertainty, we don't know, is becoming the risk. And for me as a scientist not trained in science communication, that was really an aha moment, that they're really perceiving the uncertainty, not knowing that this is becoming actually the risk in the public debate. There's other factors that are important over here. And I've shown you the picture in the beginning of the dead albatross, really. And I would make the argument that really the visibility of plastic pollution was the main driving force in forming this public consensus that plastic pollution is unacceptable. And we need to think about that. That's not a scientific argument. People see plastic, they touch plastic, they have agency over it, they can clean it up. And that's really motivating public opinion. And I would even make the argument that there is a much larger societal context in which we have to frame plastic pollution. I would make the argument that the publics are using plastic pollution just as a symbol to express their concerns about larger Anthropocene issues, such as the climate crisis or biodiversity loss, just because they can see it, they can touch it. So it becomes this proxy for talking about very many other things. And this is why I would conclude that we need to have a scientific debate. Our debate needs to be informed by the best scientific evidence that we can get. But we also need to consider that it's a really value-laden discussion that we are having. And I believe by focusing just on ecological risk and toxicity, we're really making a shortcut there, and we should really broaden the conversation about all the other issues in the Anthropocene. So thank you.